All right, in this video we're going to look at slightly more advanced SQL queries, group by, order by, and join. And we'll get a sense of some of the power of working with SQL and with relational databases with these advanced queries. These queries aren't necessarily advanced in the wider scheme of things, but as far as we're concerned, they're slightly more advanced than the select and insert and create tables that we did earlier. I'm going to begin by starting up an SQLite client, but before I do, I'm just going to do an ls, and remember in Windows it's dir, to list out the files that are here and make sure that session2db is where I think it is. That's so that when I do an open, I don't fall into that trap of opening a new file instead of an old file. And I'm going to use the tables command to confirm that I've opened up an existing database. Now, the first thing we want to look at is group by. And we're going to use group by with the revenue table. Let's take a look at our revenue table. Now, I'm remembering that without our special commands, our results come out in kind of a less readable format. Now we're seeing the results clearly. And again, don't forget, you can use up arrow to get previous commands. Okay, so now I think I'm going to move this window up a little so it's a little closer to the middle of the screen. Now, working with this, I want to show you the group by command. The idea in a group by is that when one column has repeating data, we may want to aggregate the data based on the value in that column. For example, this is a simulated table showing a number of companies and the amount that was spent by each company. So maybe and then you can see that each company comes from a different state. Now, one of the things that we might be interested in knowing is how many companies come from each state. Maybe if this was a client list, we'd be interested in knowing which state holds the most companies that we work with. In other words, should we focus on New York or New Jersey? I mean, where are we seeing the most business? So we can do that quite easily with something called a group by. And we can say select state and count of state. That was weird. Select state and count of state from revenue, group by state. This statement is saying I want to see the state column and I also want to see a count of the states. And I'd like you to group these results by states. So saying count of state means we're going to see how many times the state appeared in the table. There are 2 New Jersey companies, 3 New York companies, and 2 Pennsylvania companies. By the same token, we might be interested in knowing how much revenue or how much cost was committed by each state. In other words, not by each company, but overall by each state. And we can do the same thing here with another group by. So we'll select state and sum of state from revenue, group by state. Okay, that did not work because I said sum of state. What I really want is the sum of cost. With the count, I could have said count of anything. Maybe I should have said count of company. That would have made more sense. And then let's do a quick select of everything so you can see the difference. Okay, so focusing on these 2 queries and their results, you can see that the sum by state shows us the sum of values by state, and you can manually add them up yourself if you want. you'll find that if you add up all the New Jersey, there are 2 New Jersey rows, they add up to 265. There are 3 New York rows, and add those up to 133, and Pennsylvania to 263. And we said that by saying select the state and the sum of cost from revenue grouped by state. So it shows us the state, the sum of cost, and that's it. And the same thing with the count. You can select the state and the count of the companies in that state from revenue grouping by state. And this is called an aggregation or a group by. And it does what you're seeing. It lets us aggregate results based on one column. That column will most often have repeating data in the column so that we can group those together into multiple rows per value. So 2 rows for New Jersey, 3 for New York, etc. And then to do either a count or a sum or some other function to generate an aggregate view on that data. The next we want to look at is order by, and we can go ahead and order by whatever we'd like. Why don't we do that last one that gave us, let's say, a sum of cost. And maybe we'd be interested in ordering by cost. So I can use an order by. This is going to order the results by the sum of cost. And if I wanted to go in reverse order, I can say AS or DESC, meaning descending. And that means that it's going to order in reverse order. I can also order by any column I wish. Maybe I'd like to order by state, alphabetically, for example. Now it's ordering with New Jersey first, then New York, then Pennsylvania. And if I change it to descending, it'll reverse the sort. So order by is our way of sorting our search results. The last advanced statement that I'd like to show you is a group by. I'm going to once again take a look at my tables here. And we're going to focus on students and student status. Student status orig, I believe, is a backup that I should have deleted a long time ago. But let's take a look at these. I'm going to select star from student status. I'm going to select star from students. And I'm seeing an ID in both columns. Now, you can see that the GPA and the grad date for each one of these students is in one table, and the student's address, city, and state, and zip are in another table. Now, this is very common in relational databases because relational databases oftentimes will split out the data that they're storing into different tables when they do different things. These particular table rows are all one-to-one relationships, so I'm not able to show you the thing about joining on many-to-one, but we might get into that in class. For now, I just want to show you how you can join tables if what we wanted to do was join some of this information together. For instance, I might want to select certain columns from each table and join them together so that they're in all one table. Notice the ID column in each of these tables. You can see we've got some IDs that are common between the two tables. This ID column is the column we're going to use for joining. And I just want to make sure I get my join query correct. So I'm going to make sure that I have my correct query in front of me. I'm going to go ahead and do a join for the two tables, something called a left join that will join those two tables. Now normally, I was lazy in doing this, but normally I would make my non-table values uppercase. I just forgot this time. But let's look at what I'm asking for here. Select star from students, left join student status on student ID, student's ID equals student status ID. This is how a join works. And really, I want to make this uppercase so that you can see it just a little more clearly. So I'm going to fix it. This is, again, a stylistic thing. SQLite will not care either way, but I think that putting it in uppercase helps us read it a little better. So what do you see here? Select star, which means select all columns from students. And you look at the students. You've got an ID, address, city, state, and zip. Left join, student status, meaning we're going to join with the other table. And we're going to join on this ID column, saying that the student's ID column should be equal to the student status ID column. Adding a semicolon. Now you can see that this is including data, or what seems to be data, from both tables. It is repeating the ID column, and there are ways we can avoid that. But for right now, I want you to see that it has lined up all of the values in the student status table with the students table, so that we have one big table that has just the all the columns and rows from both tables. But actually, does it? I notice here that there are 4 rows in the student status table, but if you look to the right of our join, you can see that one of those rows is not represented. That's the B29 row. Do you see that? The row with ID B29, that one is not included. Why is that? Because the students table doesn't have it. So when we do a left join and we're seeing a table on the left, which would be students, and a table on the right, which would be student status. Why is students on the left? Because we put it on the left here and the right one on here. A left join says, show me all the rows in the left table and then show me any matching rows in the right table. We could do the reverse by switching the two. We'll do a left join. I'm going to use the up arrow to bring up my last query. And I'm now going to put student status on the left and students on the right. And now we're going to see the reverse. And notice that there are a lot more rows in the students table than in the student status table, which means that we're seeing only those rows from the student status table and any matching rows in the students table. This is another left join. Now, other databases support right joins, which means you could say the original students and student status and say a right join, and it would give us what we had here. But we can also do it as a left join. There's another join called inner join that will show us only those rows that are common to both tables. In this case, I hope you can see, it'll just be the first 3 rows of what we saw above, JK43, JAB44, and AP172, because only those 3 are common to both tables. The B29 is excluded because it was only common to one table, only included in one table, and some of these other rows are also excluded because they're not in the other table. So we only have common rows here. There's one other join that would actually include all rows from both tables, and that's called the outer join. However, unfortunately, SQLite does not support outer joins. Too bad. It's something that's supported by most other databases, particularly MySQL, Oracle, and all the other major databases, Postgres, that have, that are more designed for the larger business enterprise purpose. As I mentioned in the beginning, SQLite is a small, lightweight database that does most of what you need for most basic needs in SQL. And it's designed to be very lightweight and usable in small devices or other computers that don't have a lot of processing or memory power or storage amount. So those are the 3 queries. And I guess the last thing that I could show you is that it's possible to combine many of the things that we've done. For instance, joining and order by We could order by, let's say, grad date, ascending, and that would reorder the results so that the grad date is the controlling, or do descending to C. And it's also possible to work with this data and do a group by as well as a join. I don't have an example for you here. It can make the SQL get a little bit hairy, but fortunately I'm only asking for that in an extra credit in this session. And what you have now in all of the queries that we've talked about is all you'll need for the projects that we're working on. But that is a basic rundown of the most basic things that we do with SQL. We do selects. We do select with where. We do we do create table. We do drop table. We do insert into. There's also another query called update, which will change a row. And then we also looked at some sub-queries, group by, order by, and join. And that's a basic rundown of really what you need for to do quite a bit of work in SQL. It's served me very well over a great number of years as a developer, and didn't have any problems working with SQL and not knowing too much more than this. Although sometimes learning advanced querying can be extremely powerful. And so once again, if you want to get a firmer and a stronger rundown of how to use SQL, you can take a course in it, or you can use W3 Schools. Remember, W3 Schools to learn much more about SQL.